It's my pleasure now to introduce our next speaker, who is Andrea ONETTI. Andrea is from STMicroelectronics, where he's the Executive Vice President of the MEMS subgroup, Vice President, and he's been in that position since earlier this year, but has got a strong history with ST, spent a lot of time with analog and with audio, and obviously a lot of times with sensors and actuators. So please give a warm welcome to Andrea.
Wow, such an audience. So Tiny is really big, I could say, in this big event. So let's have a journey together and trying to have some thoughts about brains into sensor with AI in the edge. And I would like to start from a book that was really a Bible for the couple relationship. It's something that's been published beginning of 90s that is talking about two different animals, the man and the women. And the men are from Mars, the women are from Venus, and such a day, they basically decide to couple and to go to the Earth. They are very different each other. And here we are talking about something that is very similar to what is happening today. We have the sensors that are pretty much exhaustive in doing their own job. They are very, very excited to complete their task. And then we have the DSPs that likes to make continuous improvement any single day in this planet that is called Earth. And same as by what it was happening to the men coming from Mars and the ladies and the women coming from Venus, we are now on the Earth to tackle one of the major issues of the day, to try to support the sensorization of this planet. We are in the MEMS journey on something that is quite long in terms of time. In the past 2 decades, we moved from what it was just the so-called offline era, where for the first time, the MEMS technology moved from a concept to a product. And there was a major paradigm change in the man-machine interface. For the first time, we used the sensor that were basically used as standalone object. Then in the past 10 years, the thing changed dramatically. The sensorization started to become real, thanks also to the fact that there was an improvement of performances that made possible a lot of things. Of course, by having the sensors completely supported by ecosystem. And performance improvement and technology fusion allow to do a lot of things. But now we are moving to the new era, to the next decade, to what we are living today, what we called the Onlife Era. There is no more distinction in being offline or online. We are just on life. There is a fusion of technology and life where standalone devices are able to sense, process, and act. For the first time, we need to have together sensor and actuation. Of course, there is something to pay here, because at the moment that we have been in the offline era, everything was fragmented. It was the simplest configuration ever. We had independent system. When we moved to the online era, everything was connected, intertwined nodes enable efficient data exchange. But now, in the Onlife era, we need to have trained system. And we need to have edge AI in order to have local decision really on the node. And why? Because we want and we must. As citizens of this planet, we must be able to be sustainable. If we think that everything will be sensorized, we need any way to understand that is not absolutely sustainable in terms of energy consumption. If we wanted to go to a solution that can be supported in terms of sustainability, we must go to something that is trained in the edge. And this is something that is not just the vision of ST. We are basically, as a community, sharing the same value. If you look, for instance, at what is happening to the Industry 5.0, and here there is the transition from the 4 to the 5, you see that the pillars are talking about human centricity, resilience, and mainly sustainability. And this is basically what this community wants also to provide as value to this world. We are not just playing with piece of technology. We want really to have a piece of technology that can enable this on-life change. Which are the challenges for sensor in edge AI? Because we are talking about a lot of different things. But here, what is the key factors that can enable this transition? We need super tiny silicon, of course, something that is pretty small in order to be put everywhere. But as per what has been already mentioned, we need to have an optimal power per performance capabilities. This is key. We need to have a sensorization that can be sustainable. But we need also to have something that is real, that can go for a plug and play versus existing solution that we have. We don't have to invent a technology that can be used in the future. We need to have something that can be available today. So it's important to have not just available solutions that can enable these features, but we need also to have a full ecosystem compatibility and to have availability of advanced tools for increased productivity that can be immediately available to everyone. So basically, what is the concept here? We are migrating the intelligent processing from on the edge to in the edge. And in this journey, we are not just going through architecture where we have a sensor plus a microcontroller that are put together. We need to make one step beyond. That cannot be even just to have a RPU, so reconfigurable processing unit. We need to move one step further in this on-life journey by having solutions like intelligence sensor processing unit that can be integrated directly in the ASIC of the sensor. So we are not having any add-on on our solutions. We are just putting together something fully programmable, really inside the ASIC of the sensor, by having the capability of trading off on versus which are the constraints of availability of the technology of the day. And at the end, we have the magic. We have the couple of two different, completely different animals that can live together. The man that can from Mars and the lady that can come from Venus can finally couple in a single piece of silicon that is called ISPU and is available. And here, which are the things, which are the magic that can make everybody excited in the community. You can immediately go and play with it, thanks to the fact that you don't have just optimization, so power consumption versus performance that are absolutely excellent, in something that is absolutely standard, so that can go and make a plug and play of existing solution in terms of sensor accuracy and sensor availability. But then you can really start to play with AI, with immediate capabilities. The magic words are interoperability. You can play with machine learning and deep learning. And the other magic word is efficiency. You can have the possibility to program in floating point, in BNN, or in HBNN, with the full flexibility here. And of course, if I needed to come back with a magic number, by having this solution fully integrated, and by having the ISPU integrated in a 6-axis for sensor fusion, we can have a 5 times less power consumption for sensor fusion in this implementation versus what in this is done with the general purpose MCU. What is the ISP efficiency for neural network? Of course, as I mentioned, we are quite flexible. So we can play from the floating point to the hybrid binary neural network to the binary neural network. We have benchmarks that are giving us the possibility to evolve and really to reduce by far what is the power consumption here. And we can see that in terms of efficiency, we can have something that is de facto not just flexible, but is sustainable. Let's go to see also which are level of implementation in terms of efficiency in real HBNN use cases. We have digit gesture recognition, where we can go and to have applications that are just consuming 50 microjoule. In cooperation also with partners, again around the tinyML community, such as ETH Zurich, we have been able to have presence detection. And we have a good balancing between the floating point and the binarized layers in order to have everything done with 10 microjoule. And then in the standard industrial, for just a fun anomaly detection, with just a 3 microjoule, we can have the possibility to do the job. So something that is real, where people can go and can play. And I was mentioning, everybody can immediately go and take the advantage of this flexibility by working either in machine learning, either in deep learning, because ISPU delivers more options and a great level of freedom in order to use any kind of tools that are immediately available, either in the machine learning, either in the deep learning. I was questioning, but at the moment that we are here, what we can do together. Because the big advantage of the tinyML community is that can immediately go and provide feedback, and by having solution in the hands, can immediately go and play and provide a good level of benchmark. We know that we have a package that is immediately for plug and play. We have super performances in terms of energy consumption. We have full interoperability with tools. And we have also, for the ones that don't want to play with AI, the possibility to be easily programmable with AI commercial models, such as NanoEdge AI, that here can provide you the possibility to assess immediately the core. And we are here to be open for ideas that can come from the community in order to work and play with it. Why? Because if we talk about AI, tinyML solutions, we have a lot of proven benchmark for audio and vision. This is something that is, let me say, the bread and butter, where a lot has been done here. Much less is available in terms of industry benchmarks on what is around the inertial sensor. And here what we are asking to the community is to get feedback on what we call the BET, bytes, energy, and time, what is required in order to perform these specific features. Well, of course, we are a semiconductor company, and so we are the first that are trying to take advantage of it. So we are needed to move wafers, and we have robotic arms that are handling wafers any single day of our production. And what we have done is to do some benchmark in-house in order to understand what it might happen if we are working absolutely in the standard mode, what we call the offline, where basically we have per year on 1% of wafers that are scratched by the robotic arm that is moving in our production facility. At the moment that we are just connected online and we are putting some traditional algorithms, we have seen that we can improve, but still we have 0.1% of wafers per year that are completely wasted, plus a lot of machine calibration time that is affecting the performances. At the moment that we put a module based on an ISPU on the robotic arms of our factories, facilities, we see that it can really improve and go to a complete no wafer wasting. This is an industrial benchmark that we do in-house in order to see that the things really can help and can work with a wide range of flexibility. So where do we go from here? In the edge is calling for a new ecosystem. And we needed to go together in order to have an ecosystem development that can really reinforce what is available around the combination of ISPU and sensor. We need to go with new benchmark and design tools that can be really designed and supported by the contribution of the community here. And then we need all together to work in order to raise overall productivity and achieve synergies. So which are the takeaways of the day? For sure, Martians and Venusians are made to learn from each other, even if they are different. The ISPU is something that is absolutely real, and developers are already playing with it. ISPU empowers more than 10 million plus language C developers that can use AI in the edge. And what is even more important, this kind of solution, ISPU-based, can make the Onlife possible and sustainable. Thank you.
It was excellent, very inspiring. Thank you. Do you have any questions?
Hello. So yeah, I don't want to compare, but just I'm a little kind of confused about like the solution you provide and what's being presented by bots about the power. You know, in the slide before it was showing 6 microamp, and here with this novel new technology where you stack everything together, it's still in the 100 microamp. So just want to kind of clarify this point.
Yes. So again, what I was looking here, and let's go to this kind of implementation. So basically, what in this moment we are basically doing, instead to have just a sensor plus an MCU that are coupled together, we are basically implementing a specific core, or specific DSP core, who has the capability to run AI algorithm. So something like a floating point, hybrid binary neural network and neural network directly inside the ASIC of the sensor. So you don't have an add-on. You have basically the possibility really to go and work in a full integrated mode. If I'm making the comparison, just to give you the answer, if I was doing and running in a standard configuration with a general purpose MCU, these are the performances on 6-axis sensor fusion. If we are running with the ISPU, the benefit is 5 times. So if I'm comparing apple to apple, this is what in this moment can come.
And we are very thankful for our sponsors. The premier sponsor this year is Edge and Pulse. And then executive sponsors are ARM, DeepLight, Qualcomm, and Syntiant. Platinum sponsor, Analog Devices, BrainChip, Infineon, Clickertech, Latent AI, NXP, Reality AI, Renaissance, Sony Semiconductor, and Synaptics. Really very diverse company, great companies who are really driving tinyML forward. Gold sponsors for the Hub, MicroAI, Prophecy, Seed Studio, SenseML, STMicroelectronics, SynSense, XMOS. And we have a list of civil sponsors: Avion Devices, Aspinity, Seva, EMSA, Greenwave Technologies, Gravity, Hymix, HOTG, Imagimob, Itemis, Lattice, Nota, OmniML, PixArt, Plumerai, Kixo, Rachner, Rixen, SAP, StreamAnalyze, Texel, and Google. So we are very thankful for their support and, more importantly, for them being part of this community and driving it forward.